know that. So we already know that. So we know if y equals e to the x, then dy dx or y dash is e to the x. We already established that last lesson. We also know that if y equals a constant times e to the x, where k is a constant, then y dash or dy dx is as well k times e to the function of x, which is just ke to the kx. Now there is a new rule, all right? So, however, if you want to differentiate something of the form e to the ax plus b, so this is what we're doing new today. We already know those top two rules, all right? However, if y equals e to the ax plus b, where a and b are just constants, so that might be like e to the 2x plus 3 or something like that, where a and b are constants, then dy dx will be a times e to the ax plus b, which is a e to the ax plus b. Now, I'm going to prove that to you by using the chain rule. So I'm going to use the chain rule to prove the result. Basically, what this is saying is if y equals something like e to the, let's say a is 2 and b is 3, e to the 2x plus 3, it's basically you write the e to the ax plus b out, but then what we're really just doing is differentiating the ax plus b. If you differentiate ax plus b, you get a. All right, so I'll prove this using the chain rule. Now, proof. Y equals e to the ax plus b. So this is my new rule. All right, so basically the derivative is what you've got, e to the power of whatever, times the coefficient of the x or the derivative of the ax plus b. So if I differentiate ax plus b, I just get a. If that was 7x plus 5, I would get 7 for my derivative. All right? Now, proof. If I let y equal e to the ax plus b, if y equals e to the ax plus b, and if I let u equal ax plus b, right? I'm just doing chain rule here for the proof. What would be du dx? No. So, if y equals e to the ax plus b, if I let the power there be u, how do I differentiate u with respect to x? Yeah, u dash, but what would it be? Differentiate this, you just get a. Good. Now, so if y equals e to the ax plus b and I let u equal ax plus b, doesn't y equal e to the u? Yes or no? Yep. So what's dy du? So I've got that little bit, that part there. So y equals that. I let u be the power, right? So I'm just doing du dx here and I get a. If y equals that, and again, if u is the power, I could say that y equals e to the power of u, just from what we did yesterday. How do you differentiate e to the x, for example? E to the x, e to the u, if you differentiate that with respect to u, it's e to the u, all right? But what I'm trying to really do is differentiate y with respect to x. So, just got those on the side. Dy dx, but is, I don't have dy dx. I've only got du dx and dy du. Do you remember what I do here? It's dy d times something. What have I got? I've got these two. So girls, I'm trying to do dy dx here and pretend you don't know the rule, right? If you want to differentiate y equals e to the ax plus b, what you need is dy dx. Now, I don't know, let's say I don't know what the rule is. But what I've done, I've made a substitution. I've let u equal this power. So u is ax plus b. So if I want to differentiate this, I do du dx. Do you understand why? Because u is out the front and x is there. U is a function of x. So du dx is a. Right? If I go back to the original function and I've already let u equal ax plus b, I can just write my function as y equals e to the u. Now I already know how to differentiate that from last lesson. If that was y equals e to the x, then dy dx would be e to the x. This is, if y equals e to the u, then dy du, the derivative of y with respect to u, is e to the u. Now, what I really want to do is dy dx. So, dy dx is dy du times, I have to use these two, du dx. You've got to flip the other one upside down. Okay? Now, what's dy du? E to the u times, what's du dx? A. So therefore, the derivative is a times e to the u. Now, what's e to the u? E to the ax plus b. So we've just proven the rule. That's all. All I've done is the proof. You don't have to do the proof. Okay? You don't need to do the proof. All right? It's just showing that if you're trying to differentiate e to the ax plus b, yes, you write out the e to the ax plus b times the derivative of the ax plus b, which is just a. Okay? If I do examples, you'll get it better. All right? Sheet is this. If y equals e to some function of x, the derivative is, you just write out e to the function of x, but you've got to times it by the derivative of the function that's sitting up there. All right, so it's f dashed x times e to the function of x. I'm going to do a whole lot of examples. You'll be fine with it, but that's what you see on your formula sheet. What you don't see on your formula sheet is this a business at the front, but a is the derivative of ax plus b. If I differentiate ax plus b, I get a. All right? Well, because if y equals e to the x, then dy dx is e to the x times, what do you get when you differentiate x or 1x? 1 times 1 is e to the x. So it does work. Okay? All right. So let's look at some examples. So let's differentiate the following. So y equals e to the 2x plus 3. So dy dx is, so, ready? We know that when you differentiate an exponential function, you get that same exponential function. So dy dx is 2x plus 3 times, that's not just an x, so I just need to differentiate it, times 2. That's it. 2e to the 2x plus 3. All right, another one. If y equals 6e to the negative 2x plus 5. Oh, wait, maybe I'm going in a bit hard there. That's all right, you'll be fine. All right. All right. What happened yesterday when that 6 was out the front or the day before? 6 just stays there. So times, right, we've still got this. So when you differentiate that, the 6 is a constant, good. You still write out your exponential times, but it's not e to the x, so I have to differentiate what's up there. My power, what do I get? Okay, so you still get the same thing, but then you just got to differentiate what's up the top. Remember, the rule is the following. If y equals e to the function of x, then dy dx is e to the function of x times the derivative. Okay? But they put the derivative out the front. I like to do my rule and then I look up, and if there's a function up there, I need to differentiate it as well. All right? So that would be negative 12e to the negative 2x plus 5. Another one. What have I just written there? Oh yeah, sorry. My line's just gone too high up. Times negative 2, yeah. All right, if y equals e to the negative 1/3 x, what's dy dx? It's just e to that times the Now, sometimes there's no b. The b is 0. So you do e to that function times the derivative of that function. So you apply the rule. We know the rule is to write the same thing out. But if there's a function up there, you have to differentiate it. So how do you differentiate negative 1/3 x? It's just negative 1/3. That's the constant. It's like differentiating 2x. If it was negative 2x, you'd put negative 2. All right, so it's negative 1/3 e to the negative 1/3 x. Now, as someone was just asking, you could, if you want, it's negative 1/3. You could write e to the third x on the denominator. Are you okay with that? E to the negative power means 1 over. Yes? I could have also done that over here. The negative 12 is on the numerator. I could have written e to the... Actually, do not do that for this one, because you've got more than one. You can't do that. Don't do that up there, because you'd have to factorize out the negatives here, and it's too dangerous to do. Don't do it. So what I'd have to do here, if I want to do that, that really is negative 12. I'll just show you why you shouldn't do it. That is e to the negative bracket 2x plus or minus 5. So this is why you don't go doing it. You might do it if you've got one term, but don't do it if you've got more than one term up here, because it's the negative of that. So it would be negative 12 over e to the 2x minus 5. So I would not start playing around with it. Do you understand? Just leave it. There's nothing wrong with leaving it in that format. So if you want to bring that down, you've got to be very, very careful, because once you've got more than two terms here, because it's the negative of that expression. So I need to put this in brackets here before I go 1 over. So please don't, just leave it there. Don't go putting the exponential on the denominator, because you're just going to get into trouble if there's more than one term. So just leave it there. You don't need to go moving it. All right. All right. We'll keep going. Just use some new notation. If function of x is e to the negative 3x minus 6, what's f dashed x? So what do we do? The derivative of an exponential is the same function times, differentiate what's up there and what is up. Differentiate, so times negative 3. And always just put that in front now. So it's negative 3 e to the negative 3x minus 6. Oh. One sec. So, ready with the first one? So f dashed x, question 3b, differentiate the following. Function of x is e to the power of 2x minus e to the power of negative 3x. What have we got? E to the power of 2x times, differentiate the function, minus, be careful, e to the negative 3x times, differentiate the minus 3x, and you get negative 3. So put the numbers in front. So 2e to the x, is this going to be a plus? Minus that times a negative, plus 3e to the negative 3x. So that's your derivative there. Do the next one. Now the 4 is just a constant. It's like a quarter out the front. So you can just keep it over the 4. It's like having the 4 on the numerator, but it's on the denominator. We can't go moving it to the numerator. So the derivative will be, just keep the 4 there, e to the 4x times what? Yeah, so you write out the function. The constant just stays where it is, times differentiate 4x, and you get 4, plus the other one, keep the constant there, differentiate e to the 5x, and you get e to the 5x times 5. The derivative of 5x is 5. What happens with the 4s and the 5s? They cancel. That is the same. You could have written it. I'll show you another way to write it in a minute. The 4s cancel, and you get e to the 4x plus e to the 5x. Now, the other way you could have done it is written the following. Rewritten the question as follows. That is a quarter times e to the 4x plus 1/5 times e to the 5x. It's the same thing as writing it that way. When something is over 4, that's a quarter of it. 4 is on the denominator. So that the f dashed x, if I want to do it this way, it would be a quarter times e to the 4x times 4. But you know what? I think the other way was better. 1/5 times e to the 5x times 5. And then you'd get the 4's cancelling that way. I really think if you've just got the constant there, just leave it where it is. It's much better. All right? All right. Function of x equals e to the negative x plus 3. So function of x equals e to the power of negative x plus 3. You don't need to put any brackets. F dashed x is just e to that power times the derivative of negative x plus 3, which is what? Negative 1. So now we just put a negative 1 in front, or just a negative. The next part is asking us to find f dashed x in exact form when x is 0. So you just write f dashed 0. So that's f dashed x when x is 0. You're just finding f dashed 0, which is negative e to the negative 0 plus 3. Don't worry about the negative 0. What is it? Is it negative e to the 3 or negative e to the negative 3? What's 0? 0, negative 0 is just 0. It's just a normal 3. Good. Okay. And what is that approximately equal to? E is a bit less than 3. So 3 cubes, 27. Let's estimate. About negative 25 or something? Whatever. Right, f dashed 4. That is negative e to the negative 4 plus 3. Are we okay with that? We're just replacing. So this is what f dashed x is. We're just replacing the x with our number. That is negative e to the what? Negative 1. Now you can write it nicely. Negative what? What's e to the negative 1 mean? Negative power means 1 over. So that's negative 1 over e. Okay? Now, why am I writing it as over? Because there's only one term here with the power. I wouldn't do it if there were 2 terms, or I've got to take out the negative if there's more than one term. Okay, now something new that you may not have seen, but you'll see it more next year, is find f dashed x, f double dashed x, f triple dashed x, and f to the power of 4. What do you think that means? Keep differentiating. Yep. So we've got y equals e to the 2x. Oh, sorry. I'm going to write function of x. So I'm going to write function of x equals e to the 2x. F dashed x is this is called my first derivative. So what do? E to the 2x times 2, which is, we good? So I'm going to call it function of x because it is a function in x. The first derivative is 2e to the x. Keep going. Do the second derivative. So this is called the first derivative. This is called, the next one is called the second derivative, and so on. So I've got to differentiate that one. So what do I get? So I get 2e to the 2x. I write that out, times, differentiate that top bit, and I get 2, which is 4e to the 2x. And then the third derivative, because that's the constant times e to the function of x. It's 4 that times, differentiate the power again, and you can see what's happening. That's the third derivative, and so on. Now, you can only do 3 dashes, then you've got to do numbers, but you won't be doing them. You okay? So it's the constant times the exponential times the derivative of that. You can see the pattern. The pattern is that your answer just doubles. So you're using a combination of just normal x's and e's. What have we got? So isn't it 5 times 2x, which is 10x, minus, differentiate that, and you get 4, minus, write this out, 3 e to the, so it's constant, times differentiate that, you get the same thing, but you've got to times it by what? Times negative 1. So now fixing that up, I'm just going to put in brackets, that's one term, isn't it? So I've got 10x minus 4, be careful, what am I going to get here? Plus 3e to the negative x. Now, in this case and this case only, you could Look, the question is written with a negative x power. You don't have to write the answer as, this is the same as 3 over e to the x, but there's no need to change it because the question is written with a negative exponential power. All right, you can leave it. But that would be 3 over e to the x if you want to change it. But if I had more than one thing written there, I wouldn't touch it. All right, let's look at the next two. Before you differentiate that, girls, I can't differentiate it in that format. What does cubed root mean? Power of a third. So I'm still just playing around with how it looks before I differentiate it. So that is e to the x to the power of a third. Now, can you write this as a fraction? I want one power here. What do I do with the x and the third? I multiply them, and I get a third x, or x on 3. So now I'm just differentiating that. So before you differentiate something like this, you need to change how it looks. Now, you could write that as x over 3 or 1/3 x. It's the same thing. So now y dash or dy dx is, write that out, and times by the derivative of a third x, which is a third. So your answer is, now, because the question is written with cubed roots and x's, you should be writing the answer the same way. Now, the 3 is definitely on the denominator, yes? Now, e to the 1/3 x is just, I can now go and write it back out in the format that the question was given. E to the 1/3 x is this. Times a third means put it over 3. So that is now written in the same way that the question was presented to you. So this is, look, e to the 1/3 x over 3, yes? Now, e to the 1/3 x, I can see, is the cubed root of x, because 1/3 x is x on 3, if you want to write it like that, x on 3. The fractional power, the 1/3, is the cubed root, and x is the whole power. Okay, or you can see it here. E to the 1/3 x is the cubed root of e to the x. That is if you wanted to write, or if you're asked to write it in the same format as the question was presented. All right, this one, before you start, you have to rewrite it. Isn't that just 1 over ex to the power of, what's the square root? A half, okay. So that is 1 over e to the half x. Now, I can't differentiate like that. This, I only know how to differentiate e to the power of something. So how am I going to rewrite that? E to the, I need to bring it up to the numerator, negative a half x. Once I've changed the way it looks and put it into the format that I know how to differentiate, which is e to the x or e to the function of x, I can now continue. There is no rule for differentiating 1 over something, 1 over the exponential. You have to write it with a negative power. So y dash is, you just write it out, times, differentiate that, and you get negative a half. So it really is just negative, okay? Where does the 2 go? On the denominator, and we've got negative e to the negative half x. All right, let's say I want to write it the way the question was presented. The negative stays, the 2 stays, this e to the negative half x has to come back down here. So I'll put a 1 at the top. You okay with this? E to the negative half x is e to the half x on the denominator. How am I going to write it the way the question was presented to me? Negative 1 over 2 root e to the x. Because it's really x on 2. Or if you look back up here, e to the half x is the square root of e to the x. Because the half is the square root and the x is the power. Okay, so that's what y dash is.